Hey, Jess, how much time do I have? Should we, Okay, got it. 30, starting now. My screen also goes off in 30 minutes, so if this screen goes off. Anyway, thank you for having me here. My name is Jason Huggins. You are at the Python Education Summit. I am Hugs on Twitter, so that's on the top right-hand corner. That's a story for another day. Oh, I got that one. As Jess mentioned, these are the things I've started. If you're in kind of boring businessy world, you probably know these things. If not, then you don't. That's okay. I guess maybe a summary of these things is I've spent my career making virtual robots that do web testing and type words into fields and click buttons. And the summary of all this is that I was slightly frustrated in my career where I'm making these virtual robots and all I want to do is make real robots. So this talk is all about very real, tangible robots. And the way I would describe, Selenium or things like that, like this would be my go-to slide for this stuff, right? I think this is a project somewhere in Japan. I think it was like f.o.x.x. I can't find any other reference other than back to my own slides now. Like it's down the memory hole of the internet. But anyway, it's not my robot though. So I wanted to test my metaphor over all these years and to actually make a robot, a real robot that clicks buttons and things. So anyway, so this is a third generation of Angry Birds playing technology. And I think I've got some audio for these things because that's what really makes the game. I think there's an audio jack. Where did it go? Oh, it's plugged. Nah, it doesn't matter. This is just the highlights. This is actually I'm saving the torture. This is playing Heart and Soul, and a client wanted to see two robots working in tandem, and so they actually wanted to do like text messaging. It's like that's a boring demo, so I showed up with this, and they're like, "Okay, that's great, impressive, but like, can it actually do text messaging?" Like, anyway, but anyway, and then this is one really good audio. It doesn't really matter. I'm using the 2001, Blue Danube. The customer request was to turn on the phone, get to the bootloader, and then turn it off. And that's literally designed an entire robot to do that. There's no other way to do it. Well, weird stories. You can either charge it or you can get to the bootloader, two different cables, but you can't do both the same cable. It's like either splice cables or just hire me to build robots. And anyway, so did that. And then the other complaint, this is the latest version, was it's not going fast enough. So I killed that feature request. This is now 700 taps per minute. I think I can go a little bit higher, but now everything, like the walls start caving in, whatever. Anyway, so that's my day job, just putting that out there. But also, the reason why I'm here is because basically flashback to the fall/winter of 2017, not too far away. I'm also the coach for my kids' first Lego League, the Tech Club, after-school program at my kid's school. That's my son, Declan. And this is, I think, late November in the computer room. And this is the first Lego. We've got this like very large ping pong table size thing, just kind of setting up what the video I'm about to show you. And we're getting ready for the competition. And so you have to solve various robot missions and get back to home base successfully. And so Declan, this is now the returning back to home base. That's the setup for the exposition here. Again, the audio isn't so important. But they were able to drop off the blue thing in the bottom corner and then get back to home base safely. And that's my son in the top right-hand corner, Finley. That's Finley and Declan, and the other kids in the program. So we started the program actually 3 years ago. And actually based on a talk that Naomi gave at PyCon a couple years ago, I've actually been very nervous about my relationship with First Lego League, specifically because it's competition focused. And some of the things that Naomi mentioned in a talk years ago was like, I think I actually asked at PyCon, like, well, what do you think about competition-focused based programs? And a lot of them are. First is all about that. This is a slight tangent, but this is actually speaks to your point, because this is a PyCon moment, and it's kept with me for years. I saw this in this competition. We had two teams, the sixth graders, my younger son's the sixth grader, and the eighth grader team. And in the heat of battle, it's one thing to make a robot accomplish the mission, and it's great, you know, like, but now you get into this kind of weird Karate Kid finals kind of moment where you now have to not just make the robot do the thing, but defeat all other people. You end up, some kids at least, you end up ruining it because now you've taken the sweetness of just making a cool robot into this weird competitive thing. Some kids thrive in that, some kids don't, and so I've been I've got like this weird thing about First LEGO League, and I think that competition-focused thing, again, this is a slight rant, but part of the reason why I even got into this is because I saw Dean Kamen speak. If you haven't seen, he's the guy who created First. I could end up giving a whole talk about First, but I'll try to keep this short. One of the most inspirational speeches I've ever seen was Dean Kamen, and one of the reasons why we started this club was because of that talk, and he basically said, like, I'm butchering the phrase, but something along the lines of, as a culture, we are what we celebrate. And his point is, we celebrate celebrities and sports stars. And so if we want kids to be interested in engineering, we have to make it as cool to be an engineer as it is to be a music star or an athlete. And so the competitions, when you go into a First competition, they often rent out, at least the ones in Chicago where I live, for the high school level. They actually rent out UIC Pavilion, the basketball arena. You go in there, you don't know what's going on, but you can buy popcorn and a Coke and you know, watch the spectacle. And it really is as exciting as going and seeing like a sports thing, if you're into sports ball. But you get, so his thing was now, because it's a big thing, people want to sponsor it, people want to be in all of that excitement, and so kids are getting scholarships just like you would get an athletic scholarship or, anyway, so he's got this whole thing, but the problem is that you've also then inherited all of the problems of, I guess, the hero worship, or whatever you want to call it, the problems that go along with very important, impactful, whatever you want to call it, sports programs, or you know, rock bands, and just all of the bad side of it. More specifically, within the sports context of, and this I think I see in First, and we saw this in the competition. The team that won, they Team Bumblebee. Sorry to out them, but there's one little loophole in the First rules, and it really bugged me. But you can drive a truck through this loophole. You can use any Lego that Lego has manufactured ever. So you have these kits, and we only have enough money to buy these kits. But the teams that win, basically, as long as you can fit anything, as long as your thing can fit in this circle, maybe there's like a 2-foot height limit or something, you can use whatever you want. And so they went off on eBay and bought probably thousands of dollars of Lego, and once you have that, they're basically the New York Yankees of First LEGO League. And there's this feeling going away. My takeaway from First was, one, there's this competition-focused aspect of it, and some of the kids totally, like, they didn't come back this last semester. I think they just were, that's it. And I hope they, not to get all teary-eyed, but I hope I didn't ruin engineering for them just because of this weird competition thing. But the other one is, I was kind of left over Christmas break. I was kind of in a funk over this thing of, like, do I opt out? Do I just nope the whole thing on Team Bumblebee and just say, like, look, to beat them, or one, is like, okay, do I even want to beat them? No. But here we are, putting these kids into this competition. Do we opt out of competitions, or do we, if we can't beat them, join them, go and just blow more money into this whole program? So I'm really, anyway, this is a diversion, but this is really kind of sets where my mind was in the month of December, right after this competition, and where Jess kind of saw me hacking on stuff. So I'm trying to solve lots of problems. It's a rather ambitious thing, and it's going to take a lot longer than I realized. But where my head was at is that I think right where you have a program of like 10 to 20 kids, the cost, like Lego and even Apple, when you talk about like the iPads that you use to program them, they're just right. They've found this genius sweet spot of like 10 to 20 kids where you can extract the most amount of money from people. And so it's like, you know, imagine like $5,000 to $10,000. Like, oh man, that's really tough. But like, oh, it's only $5,000. Oh, maybe we can hire a grant, whatever. Meanwhile, over like in enterprise land, like that's a complete non-starter. Like you're just having to set up a server farm of thousands of machines. You absolutely will not be doing the gold-plated, you know, Macs or Dell machines in there. You're going to be doing like the absolute commodity hardware and running Linux on those things, right? So like when you've got like 100 or 1,000 stuff, absolutely, cost is totally the thing. But when we're in this setup where you got like you need 5 kits or 10 kits, the money situation, it's really hard to prioritize, well, let's just spend a year and drive the cost down to nothing. Because I'm like, well, I'll have nothing. We've lost a year of kids working and stuff. It's like, okay, fine, let's just pay the money. Anyway, side note. Well, that's my state of mind. Is even though this is not my day job, I'm really trying to figure out how to make the tech program be better. And we adopted First Lego League because it was an easy curriculum to pick up. But I would love. There are things that I don't see in this program that I would love to have, and that's kind of where my head is at. All right, I've got 20 minutes. So one of my other kind of rants here was we bought 5 kits. We had 20 kids. And my analogy here is that it's kind of like trying to teach a room full of students and you only have 1 violin. And our club, even though some clubs they meet, if it's kids and their parents, they'll work on it every day. But ours is an after-school program. We compete with lots of activities, so we meet every other week for 2 hours. So imagine if you only got to practice your violin for a shared violin with 20 other kids for 2 hours every 2 weeks. Like, how much are they actually going to learn in the environment? Also, when kids, like, sometimes they come to the one meeting and they don't come to the next one, we've got 5 different kits, so 5 different kind of robots. Then you have to spend first part of the meeting just kind of putting back, the Mr. Potato Head kind of quality to, like, getting 2 wheels and whatever. Anyways, so the other thing I'm trying to solve is if I want to get to 1 robot per child, which is a famous, well, there was the famous 1 laptop per child project, which kind of succeeded and kind of didn't, right? Cosmically it succeeded, but tactically I guess it didn't. But it's a noble cause. I would like to get to maybe not getting every kid on every continent a robot, but just specifically 1 robot for the 20 kids that I'm responsible for in Oak Park, Illinois. How do I get there, right? So some of my options, I can spend more money. That's like, if I can't beat them, join them. Go all in on, beating Team Bumblebee next year. Make the kits cheaper, or pick a different tech program. At least this talk is all about making the kits cheaper and all the implications of that. But there's other options, like I could have spent all my effort on like trying to hire apply for grants and see how that goes, but I'm not in that world, and some people do that. It's interesting though, at the bottom of the link, right under the $5,000 price tag for when you go to Lego, it says like, hey, would you, be interested in applying for grants? Like, they know everyone has some sticker shock on this stuff, so that's an option. But I'm just adopting skills from enterprise land. Like, let's just make it open source and super cheap and scale it out. Anyways, so one thing, as I'm trying to imagine, like, how can I make this the absolute cheapest? Remind me of one of my toys from my childhood. And this, I would say that this is how I learned to program. This is called Big Track, and it's super awesome. And here's a video of how you would program Big Track. It was like a $30, $40 toy from Milton Bradley's electronics division back a long time ago. And if you want to program, let's see, this next video is like, make it go forward, turn around, and come back. That's it. But you would, the point I'm showing this is part of the cost, it's not just the Legos, it's also the computer or the tablet or the fancy iPad that goes with it. And so where my head was at was like, oh my gosh, I could drive the robotics kit down to nothing, but I still have this like fancy tablet expense that blows the budget. And where the stuff is at is the Lego kit is like $400, iPad is a little bit more. For this to be kind of any better, it needs to be all in for everything needs to be cheaper than $400, ideally, right? Anyway, so I'm inspired by other things that are super cheap but super fun. You still get some learn stuff, and I remembered like, oh, there's this toy, and because it's got this little touchscreen on there or little keypad, you don't need the $400 iPad to go with it. Anyway, so this is me programming it to go forward. You have to enter, because there's no screen, you're just going to have to hope you programmed it in correctly. Back in the day, no interactive prompt. And then it goes forward. This is my office in Oak Park. Fancy wood floors. And it comes back. What's not in this demo is it also can fire laser cannons. Super cool, right? Anyway, not real lasers, but whatever. Okay, so now that's something I can't buy. That was from a long time ago. But what I can buy is like what would be the modern day equivalent. So this is a kit. I think like the actual chassis was from Micro Center, but all the electronics I got from Adafruit. And this is the little robot. This is actually the Adafruit's demo code. I think it just goes back and forth. It's actually, I mean, it's funny. I got this thing working. I'm actually SSH'd into it. Like, this is like now modern day technology. I've got my laptop, and I'm now SSH'd into my robot. And I'm now, because it's a Raspberry Pi, and I'm now telling it to fire the motors. Super awesome, right? And so like, it's like, oh, maybe I'll build a program around this, and I'll operationalize this. But then as I'm kind of playing around with that, I was thinking like, well, the problem is I still have this laptop. Like the laptop becomes now a problem. Again, this is where follow me on my imagination on how I go follow me down the rabbit hole, right? So then it's like, okay, Raspberry Pi 0. I've got it's the wireless, so I can connect to it. I've got the Adafruit motor hat for it, but I guess I made it like shoes because I put it under, whatever. The battery packs, maybe this whole thing is like $100 or so, maybe. Like 75 in components, and when you add the batteries and cables, it's probably 100. But the interesting thing is they also have a camera. This is where the rabbit hole goes, right? It's like, okay, well, if I add a camera, and let's just say I want to get rid of all the costs, which means get rid of the computer, well, how could you even program it? How could I get to something like this with this? I could put a keypad on here. That's an option. But like, let's make it, hey, it's 2018. Let's do it the most ridiculous way. And it's my project, so whatever. So like this camera, like I wonder, could I use the camera as input for? Could I actually maybe like have like a QR code or something like that of the program, and I can kind of look over the code. And this is where things get a little weird. I would have to add some kind of feedback to the kid to know that the thing was loaded. Maybe I could blink an LED, or maybe I can add a speaker, and so it actually ends up kind of backing myself into like a Siri or Cortana or Alexa kind of robot where it's talking like, oh, I've found a program. It looks syntactically correct. Would you like me to? Like, could do this whole thing where I don't have a screen, I don't have a tablet. But the key thing is, like, I'm using the Raspberry Pi to the horsepower and the camera to read things in. And so then down the rabbit hole I go, I'm now imagining what would a programming language look like, assuming that there was no tablet, and I am literally like standing over some code. The kid reads it in, and then we put it down on the ground, and then it can go. So now for the adventure, right? So I started thinking like, okay, I need to have a programming language that's going to be very bright and bold, kind of like QR codes. It's going to be very easy for the computer to read it, right? So we all know QR codes, but I stumbled into this idea. It's like, well, what about emoji?
All right, code cards, prototype number 1.
So this is the video that Jess saw.
See if it works.
All right, the audio is a little bit annoying. This is me being impressed with myself. Anyway, but okay, can find all the cards. And this is the program, right? So
yes, sweet.
Okay, so this is all Python code behind the scenes. I haven't published it yet, but I will. Maybe today, hopefully. There's a lot going on here. It seems simple, like it's a lot of like basic beginner kind of Python, OpenCV kind of stuff, but then I've actually tried to port it recently, as in like very recently, like 12 hours ago, to JavaScript, and I failed miserably, and I realized actually like reconfirming that Python was the absolute best language to prototype this stuff in. But it's not just Python, it's not just OpenCV, but it's like SK, it's a science toolkit, NumPy. There's all of these libraries and all of the documentation and tutorials. Like, it's so easy to get started here. But just like briefly, kind of jumping through like what the heck is going on here. First, it scans the screen and finds big black outlines. If I can so you can kind of do find contours. So you can have like this little thing, and it'll find a big black boundary, and I can do that. And then, but then if it's like skewed, you have to then like unskew it so it's a perfect square. Once I do that, and I'm already skipping over a bunch of stuff, then you have to then get kind of a snapshot in there, and I'm doing very simple stuff. It's not really emoji, it's more basic polygons at this point. I'm using like a triangle for start and an octagon for stop. It kind of conceptually makes sense for the start and stop of a program. Or in JavaScript, open bracket, close bracket, or white space, magical white space. I couldn't use a white space program because how would it know where the end of the program is? I couldn't, anyway, cosmic, philosophical problem. If it's not in view, is there no stop sign? Anyway, so I feel like I had to add some kind of stop sign for the code. So it would find those two things and know the code is between them. And then I'm actually using then other fancy algorithms, a match template I'm using to find these various shapes. And then I'm using another library called Tesseract, and I'm using the font, OCRB font, which then you get into some awesome machine learning stuff here. Because you're using a font designed for machine vision, a whole bunch of people have kind of standardized around that, so there's some training data that I can kind of slurp into Tesseract, so then it instantly can read the numbers there. And so it kind of this cascading thing of trying to find the algorithm, finding shapes with number of sides. 3, it's a start. 8, it's stop. Finding by template, and if it can't find that, it's all these if-else stuff. Then finds the numbers. And so this was me finally kind of getting it all working. And when it can pull it out, oops.
All right, code cards, prototype number 1.
So this was a December 15th or so. Let me fast forward here. You can kind of see that I can kind of read everything correctly. And then I also have a sheet of all these numbers, and I can read them all correctly. And kind of fun, right? So I've kind of succeeded very early on in this imagination little thing where potentially I could read a program in with just a camera. Now, granted, I was doing this on a fancy laptop, and the horsepower between that and this, it's kind of up to now to be tested to see if it's going to be fast enough. There's lots of implications, though, but one of the key things is I realized, oh my gosh, this is a real program. I can't just read it in. I actually have to have a parser, an interpreter. This is a real language, and then I realized actually this is nothing new. I've basically re-implemented Logo as a programming language, and it's one of those things I've kind of seen this in different things. When you boil something down to its absolute, simpler, but you can't possibly make it any simpler, you end up bumping into a whole bunch of other people who've already done it. So I'm not saying this is anything new. If anything, I'm realizing I'm rediscovering stuff that is decades old. And just so now I have a copy of Mindstorms that I'm reading from Seymour Papert, writing about this stuff. Anyway, so now the last couple of months, I've just been kind of really going to school on how to actually implement a programming language, but specifically through the lens of getting it read in. So emoji is annoyingly popular, but it's also my key reason for doing it is because the computers can recognize it. Anyway, so I originally called it code cards. I've moved on to calling it wildcard, because why not? This would be the hello world in everyone has to do a hello world, so this would be the quintessential hello world in wildcard. Also, for very deliberate, specific political reasons, I am purposely using the medium skin tone and the world without continents, because you have to choose otherwise, which side of the globe you emphasize. I try to get the stats on what is the literally average skin tone of the world. I don't know if there's numbers on that, but also if it's it's hello world, but it doesn't say which world. It could be a different world, so why not just use a generic globe? Anyway, so that's the hello world. I think going forward, if we do use emojis, this is going to be kind of a design decision. Which are all people created equal? This is actually an interesting kind of weird design thing of if you had a yellow hand and a differently colored hand, are those evaluated as the same, or are those different? It's almost like case-sensitive variables. You can have uppercase A and lowercase a. Are they the same thing, or are they both A? So I'm already bumping into some kind of weird design issues just with this, just with this code of how do you evaluate skin tones as different variables? Anyway, this would be other examples of Hello World and wildcard. So as you can see, it's hopefully a well-named programming language, because this is pretty wild. So just like in Python, the hash mark is a comment. So those two lines, the first two lines don't evaluate. And then this would be a speech bubble. And then I'm using the pause emoji as quote marks. Because why not, right? So that's Hello World. This would be a different one. This would be creating a function. And this would be the circle would be kind of like def in Python land, the name of the function. This would be a code block, so the start and stop, and then that would be the function. And so if you've implemented those two things as functions, that's how you would call it. That's one example. Oh, sorry, do you want to take a picture? I can show the, okay, got it. I'll show the code later. This would be example 3, where you actually you created the globe as a string, and then the hand is actually taking in, that is the emoji for a label. So then you would do hello and then label. Anyway, so it gets kind of fun and ridiculous, right? This would be this is kind of the end of screenshot of my test suite. This is where things also kind of go down another rabbit hole. This code, there's no reason why it has to be implemented right to left. Or sorry, left to right. It could be right to left. So those bottom are, I've got a couple languages in there. There's Hebrew, and I forgot the name of the language. Not Farsi. What's the, or Arabic? It's just Arabic. Okay, right, yes, Arabic also goes that way. Anyway, so I think there's like the top 14 languages. So I think the other thing is, like, going forward, I want to make sure that it's as multilingual as possible. This is how you would do numbers in wildcard, floating points, strings. This is how you do importing. So that's a box package import robot. That would be importing star. So I'm stealing a lot of stuff from Python. This would be importing one method. This would be importing several methods. This would be go forward and back. This would be a function definition. You could do it 2 ways. This would be a function call home, right? But if you want to do a function reference, I have to figure out how to do that. And this is actually an implication of not using parentheses. I have to have this difference between referring to a function versus calling it. And so the one thing I came up with, Ruby runs into this same problem as well. Those are linked paperclips. So that's a link, get it, to home, whatever. This would be how to dance. Why not? This is the kind of equivalent Python code, wildcard code. I'm super running out of time, and I want to get to a demo. So these are just like, they'll all be up on the website, but just want to give you a flavor for this ridiculous language I'm creating. But the nice thing about this is, at least on the left, forget the comments, because this is purely symbolic, there's no English keywords there at all. Potentially, this is useful. Granted, if you're going to get into the Linux kernel stuff, you're going to have to learn English eventually. But when you're just getting kids to code, potentially this is useful, and you don't have to get over the English hurdle to potentially, make your robot go forward sunglasses number of steps, right? You could also do it as a one-liner, left to right. But why not right to left, right? Or there are some languages that are top to bottom. It all works, potentially, if I implement the parser correctly. You could also, this is repeat loops, 4 items in lists. That's lions and tigers and bears. And then print, that's a printer, so print that out to console. This is the Konami code. This is my favorite. This would be syntactically, I haven't implemented it yet, but this would be syntactically correct. There's some rules that I have to figure out on how you can pass in parameters to a function and how you make that rule. I could totally, maybe I'd do a lightning talk just on how we'll happily implement functions and function parameters and all that stuff. Anyway, but the cool thing I wanted to get to is like, okay, but does it actually work? So let's see. There's the, I've got 1 minute. You know my password now. Whoops, I have to change everything now. No, seriously, I have to. Okay. my luggage, bank, everything. I don't need this. Let's see. Okay, come on. This is what I wanted to show you. Yeah, the waiting. Let's see. Got 20 seconds. I think I hit agree on the. I was hoping this didn't time out. Oh, come on. Here we go. Allow. Okay, so one thing I've learned is lighting is kind of important. But imagine this isn't actually I showed you all this code, but this would be the robot. And instead of a box, it would actually be a robot. You can replace this. This is a program called AR.js, and then this is where the project took another rabbit hole. There's this thing of like having the robotics kit, but now if I'm using, I started testing around with this with like tablets. The punchline here to this, I'm now over time. I have been testing this on like super cheap, like $50 tablets. And because they all have like these back cameras. And so there's this thing of like potentially as a starting point, again, this is like a huge project now. If the final goal is the robotics kit with some kind of way to program it, one stepping stone potentially is like just give these kids like these $50 Amazon Fire tablets, and they could implement, again, you can kind of bring this back home. We could lock it down. Whoops. Let's see if it actually still loads here. The code could potentially be read on the left, and then your robot is literally, your virtual robot is sitting right there, and then potentially I can click the green tap, and then I can program. So there's this weird thing where I'm kind of re-implementing Logo in its two forms. One is a real robot, but then two as like computer screen robot, but now it's like 3D, and potentially because it's this augmented reality thing, there's no reason why it has to be limited to only going on the tabletop. Potentially could go in 3D and paint all over the room. Anyway, so there's this weird thing where now where I'm at is even though it started with the Raspberry Pi and the camera and making a kit, I've now been spending a lot of time on just the language and this AR thing. So then like when I hit play, I can play it around here. And I'll probably be playing around with it today, just getting the software to work. And this is also kind of running up on Heroku. So if you had a phone, literally, as long as you printed this out, you could start playing around with it like right now. So it doesn't require any native applications or anything like that yet. Anyway, there's a couple other things to show, but I'm now way over time. So that's it for now. I'll be around all day, and yeah, ask me any questions later, though. Thanks.